Start from here. Okay, okay, because there is no need. Okay.
This is for me. Oh.
Okay, welcome back, everybody. This is gonna be a very, very good tutorial. need to do the presentation. So can we get the doors closed, please, in case why? My name is Awal. My colleague Makito. We're from the APNIC training delivery team, and we're going to cover a tool in this tutorial. It's called SALT, and I'm pretty sure many of you already are familiar with this tool. Not promoting this tool, but there are many other alternatives as well. We just picked one tool to just introduce or to show you some of the features it has, but there are very good other tools as well. So, like I said, my name is Awal. We have done some workshops before this conference week as well. So some of you already know me. And I'm handing over to Makito to introduce.
Yes, I'm Makito. Hello again, everyone. I believe many of you joined my workshop in the last week. Yeah, I'm the network analyst, technical trainer at APNIC. Together with Awal, I will deliver this network automation with SALT tutorial. Specifically, Awal will do the presentation first. Then after that, I will go through the GitHub, show you some configuration examples. Thank you.
Thank you, Makito. So a couple of modules, but this is a huge presentation deck. We have trimmed it down shorter to fit with this time of 1.5 hours. So we'll have some slide to introduce the SALT and some of the configuration examples. But a little bit more detail of the whole tutorial deck in terms of doing the lab and doing the configuration is coming up after this slide deck. So, okay, so SALT, it's the network automation tool that is very fast, and that is its main feature. There are some other nice automation tools as well. This SALT is built to keep the speed in mind. So its working principle and the mechanism it takes is faster. That is a very good advantage when you are running a very large network. And large means there are many industry in the internet who has several thousands of devices that could be routers, switches, servers, VMs, containers, and many other things. So if they want to do automation, because manual management could be difficult for them, challenging as well. So they might take some tools to manage and do the configuration, retrieval of the information and things like that. So very large deployments, they might think about Salt. And many of the big data center providers, cloud hosting providers might have already introduced Salt in their network management, configuration management tools. This is asynchronous. It means that you give instructions and you don't wait for the reply. You give the next instruction, and at some point they will do the job and then report you back. So you don't really wait for the task to be finished in order to initiate the next task. So it's asynchronous. You don't really need to get the report coming first before going to the next task. There are many different vendors as their corresponding agents to deal with Salt, to work with Salt. So it's a huge community support, both from commercial companies as well as from the open source community. So it's a very positive thing as well. And it has a huge customization option in order to do the work. Now, this is a simple architecture, how it works. So you have a controller, which is called master. And then the minions are the agents that will do the job that the master is saying. Means that, for example, you want to do a simple task, let's say change the host name of a router. So the agent is supposed to live in the router. And the master can give the instruction of changing the host name, and the agent will execute it in the device and will report you back that it's done. So the minions can be many, and one master should be able to manage that many numbers of minions. But of course, you can have multiple master. So simple term is a master is the controller who manages minions. Each minion takes care of one device. So it's a one-to-one mapping. So one minion, one device. But one master can actually talk to many minions. And minions are supposed to live in the corresponding device as an agent. This is extended architecture where you can have multiple masters, probably for failover and localization and things like that. That might be your requirement. So one minion can take instructions from multiple master, but eventually it will execute to one single device. So that is the relation. So like I said, minion executes the instructions as an agent in the device. Master controls, or master manages the minions, and there can be really very big number of minions that the master can actually manage. The master minion communication happens over the 0MQ or ZMQ channel, and that's why it's very fast, because it's ZMQ is very fast. And the default ports, which is customizable, of course, but the default ports for the minion is 4505, and on the master is 4506. So when the master sends an instruction to a minion, it sends the instruction over the 4505 because minion is listening to that. And then once the task is done, minion reports back to the master over the 4506 because master is listening to that, but you can customize it. How this communication begins in the first place is you have your master running, and the minion is also, let's say you just started the minion. So what will happen is in the minion, you give the address of the master. So the minion initiates the connection to the master first. And it's, and that's why minion needs to know who is my master. So in the config, in the minion config, you give the master address, and then it knocks to the master and say, I want to be your trusted agent. And then this is my key. Do you want to accept my key? And we can start, a trusted communication. And then master says, master by default denies. By default, it does not accept it. That's when you, as a sysadmin, you go and accept it, explicitly accept it, and then it becomes your trusted or accepted keys. Means now the master and minion can communicate. So that's when the public key actions happened, and then rest of the communication is now going to happen between the master and minion. If we had a chance to run the lab, but you definitely later in this session, when we show you the GitHub task that we have for the lab, which we are not going to do here, but we'll explain, and you'll see that this minion and master communication starts with this exchange of keys, and you have the chance to actually verify, and you can actually delete the keys. This means you disassociate the minion from the master. You can check and selectively accept them. There is an unsecure mode of keeping it open. Means you don't really need to go with this selective accept. Anybody who knocks the master is going to be accepted. That's called open mode, and it's not recommended because it's not very secure. Now, there are some naming conventions, and it's important for us to know as well, because when we see the configs, then this will make sense. So this ops is called options, and options is the features of Salt. So whether you want to enable or disable some of the options, there are some default options, then you can add more. Now, here's an example, whether my master minion communication do I want to do over IPv6, then you can enable this option IPv6 true. That means it will then use IPv6. The other terminology, pillar, very important one. So pillar is the configuration data, like whatever information or configuration you want to set. For example, the IP address or the interface or the host name and things like that. So these are given data by the user, what you want to set. The other one is the grains. Grains are information that's collected from the target device, because the minion as an agent always talking to the device, like corresponding device that it is managing or it is talking to. That means it from the inside, it can collect many different information. Whoever runs the Ansible, you probably know that this is called facts in Ansible. That means what is the vendor name of this product? What is the version? What is the license? What is the interface MAC addresses? What are the IP addresses? So every single piece of information that the agent can read is a grain. And grains are called attributes. In simple terms, you can say these are the information that the agent can read from the device. This is very useful. Why? Because let's say I want to set host name to my routers, let's say, or I want to set NTP server to all my devices. Now, some of my routers could be Cisco, some of my routers could be Juniper, could be Nokia, Arista, MikroTik, Huawei, many other vendors. And every vendors, usually you will see they have their own command syntax. And sometimes they are very different than each other. So let's say you want to run this NTP to set to the devices. And if the agent can understand the operating system or the vendor, and then based on that, if it can do the command syntax by itself, that's when this grain can be very useful. The grain of the vendor name, the vendor name is a grain, an agent can sense that, and then it can use the right syntax. Eventually, that will be helpful to apply the same NTP information to different types of devices coming from different vendors. So in short, pillar is the automation data that you give as a maintainer, like given information, IP address, host name, whatever information you want to set. Grains are the attributes that you can read from the device, or actually grains can be given by as a input data as well. Like, for example, the location. Let's say you have a data center in Da Nang, and those devices are in Da Nang, and that can be a grain as well. So this location information can be a grain. So that's not in the device, but you configure it. Proxy minions. Now, I was saying that minions are supposed to live inside the device, but that's a small tool, and some devices are so close that you cannot have access to install a package there. For example, a Cisco iOS router, you don't really have a chance to install a package there. Whatever is there, you just use that. You don't have like any package manager to be able to install a package there. So how can a salt agent be installed, or how can a salt agent live inside the device? It's not possible. But if it is a Linux server, for example, a Ubuntu machine, you have the option to install agent. Now, for that kind of devices where you don't have an option to install a package, the agent, instead of living in the box, can live outside the box as long as it can maintain a connection with the device. So basically, you are bringing out the agent, and that means you have an extended hand to still connect the device and get the information. But on the other hand, you have a connection with the master. So now the agent lives outside the box, and it has two hands. One goes to the master, one goes to the device. So this is the picture, the proxy minion now outside the box, and it maintains a ZMQ connection or the channel to the master. And the other hand could be one of the different connection. For example, it could be SSH, it could be netconf, it could be HTTP or REST API. So this RESTconf actually. So this type of connection options you have to still maintain with the device. Now that could be question like, I have so many devices, let's say a couple of thousands of devices, and I have to run for every single device, I have to run one minion. And let's say every minion is my proxy minion living outside the box, where I'm going to run it, and whether it needs a lot of resources to run them. This can be really very tiny containers. So you really don't need to, of course, you have to have some resources to run them, but not really that resource hungry applications. These are very tiny containers, and you can use Kubernetes to manage them as well. You can have Salt Cloud to host them in the cloud as well, as long as they can maintain these two connectivities towards the master and towards the device. It can live anywhere. So I just already covered these, that it has to maintain the connection towards master as well as towards the corresponding device that it is managing. Okay, so deployment for this huge number of minions, proxy minions, can be over different things. Like it can run in a single server, it can be distributed over multiple different places, it can be in the cloud, and it can be managed by Kubernetes for Docker containers. And they don't really not necessarily need to be very high resource setup there. Now, for some network automation tools, this is very common. YAML and Jinja. This is very common in Ansible as well. And Ansible is also very popular network automation tool. So this is not new, but I still want to cover a little bit of it. So it's helpful for you to understand the later part of the session where we show you the configurations. Okay, YAML. It's originally its name was yet another markup language. And then they changed the name to YAML Ent markup language. And it's a data serialization, you can say, like, or human-friendly data representational language. And it's basically what it does, it has two components. You see the left one is called key, the other side is called value. So it's basically a mapping of a name with a value. And you will see that it has a colon in the middle. And usually in a good representation, you will see a space. So here is an example. Location is the key or the name, you can say. And the value is Brisbane. So if I call location, I'm going to get Brisbane. Right? So it's like easy to do this type of calling and getting the information. And this is important for automation because you need to utilize some of the information. So you need to call the information. So a couple of rules, there could be many, but we're covering 3 rules. And 3 rules, very important 3 rules for YAML. Rule number 1, colon. That I just said that there is a colon in between key and the value pair. As you can see, this example, let's say interface name. And the name of the interface is Ethernet 0/0/0. And in between, I have a colon. So the colon separates the name and the value. So first the name, then the colon, and then you have the value. And second example, as you can see, let's say my interface is disabled. My key is enabled. And if I say false, means it's disabled, right? So it has a Boolean meaning, like false means 0 or true means 1, something like this. So this is a Boolean value expression as well. Second rule, indentation. When I have layered kind of keys and each of the layer is dependent on the previous layer, that's when I add indentation. And it's also very common when you do this type of, when you use these automation tools like Ansible as well, because YAML is the language there. So here at the bottom, as you can see, I have 3 layers, and the last layer is dependent on the previous layer, and the previous layer is dependent on the first layer. So I have basically interface enabled. And so I represent it as interfaces because I could have multiple interfaces, and the first interface is Ethernet 0/0/0 and enabled colon true. That means this interface is enabled. Okay. And then I can have next interface. I can have status of that interface and the next interface and so on. So if I have multiple interface, I have to maintain the indentation of it. So the layered indentation has to be maintained properly. So it is meaningful for the language itself. So here I have 3 interfaces. And if you look at the indentation of 2 spaces maintained symmetrically, so first you see the first line interface and then 2 spaces to make it a layered dependent information like the key. So Ethernet, there are 3 Ethernet interfaces and they're maintained the same column, like 2 space indentation. And each of the interfaces can have multiple characteristics, but all of them has to do another 2 indentations. As you can see, every single interface has a another key like enabled, true or false. Next rule is dash. And that's when you do a list of information for a certain a key. So here, let's say I have 3 different NTP servers. It could be IP addresses, and probably you have already seen in the Ubuntu probably after 1804, you probably have seen that their interface configs also YAML. And that's when you see that you can actually add multiple IP addresses, IPv4, IPv6, multiple DNS servers. And then when you have to configure it, you do the dash. So dash is a list of information for a certain key. Also maintain the same indentation, okay? Now here is a combination of the layered information along with the dash. So multiple values or a list of information, and then each of them has their corresponding keys. So you maintain a combination of both dash and also a layered structure. So I have first interface, and then the next interface, and they're a list. So I am just using dash, and then they're indented two spaces towards the right, means they're the dependent of the interface key. Okay, now these are the Boolean value or Boolean expression here. So where I say true or false or yes or no or on or off, these are interpreted as either 0 or 1. So true, yes, and on, they're actually Boolean 1, and then false, no, or off is 0. Now, if I have to add, let's say true, and I don't want to be interpreted as 1, I want it as a string, and then you use the quote, like the double quote can read it as it is, like the string. So the recommendation is, if you have strings, always follow the quotes. That would be the safest way. If you have multi-line text, you use the pipe and then go to the next line and follow 2-space indentation and continue with your multiple lines, and that will be a multi-line text. Here's an example. So as you can see, I have an interface and I used the double quote here. Then I have enabled true, and that's, I don't really want true to be as a string. I want its Boolean value, because that's how it will work as a interface, to be up or to be down. So I don't want this true within the quotes. So I just kept it like that. But if you see the description, if you see the MAC addresses and the IDs, so description and MAC address, these are like longer string, and I want it as it is, so I just use double quotes. Okay, now comes this Jinja. Jinja is the templating engine, and you see the Python templating engine. This one is used both for, you probably have seen it's used in Ansible as well, and as well as it's also used in Salt. And probably you have seen, if you are using Ansible, the template file ends with the .j2 usually to indicate that it's a Jinja template. For Salt, you will see it's .jinja. So there's like minor difference. Now, what is a template? A template is, so when you need to use something that you need to use repeatedly, but with minor changes in it. For example, the email template. For example, your link goes down. You probably need to notify the customers. The first email goes like almost the same language that you want to reuse for the next type email of this type of incident, and you create a template. And in the template, there are some changing values, and that's the variables. And when you give an input, so when you create the template, you keep it as a variable, and when you give an input, the variable is replaced with that input, and that becomes the furnished version of the template. So a template needs, the template can or cannot have a variable, but without the variable, probably you don't need to really do a templating. It can be just a static file. So here's the template, and then when we give the input data to make the template specific to that purpose. So here is example, I have a Jinja template. Inside the Jinja template, I have this string called interface is, and then to indicate a variable, I have the double curly bracket. So this interface name is the variable. And when I give an input when I put a value against this variable and I pass it to the template, the result becomes, let's say, interface is gigabit 0/0/0 because the variable has been replaced with its value. Second rule is the conditional test. So when we say condition, means we'll use if else. Okay, so this is an example where I'm changing the interface. Sorry, if my interface is matched with a certain condition and then I want a certain result. And so when I do the conditional statements, you'll see that I'm using a curly bracket and the % sign. And then when you're closing it, I'll use the opposite, like the % and then curly bracket. And so the first line here is you can see that if the interface name is a certain string XC000, then I want to print a line called the interface is 10 gig Ethernet. And if the interface is gigabit 000, I want to print a line, the interface is gigabit Ethernet. And anything else, I want to print a different interface type. And that's the end of the condition. And now I'm going to pass some value to this condition. And each of the conditional statements will be matched starting from the first line. And if there is a match, then it will stop reading it. It will just execute where it matched. So here, if I use this conditional test against my previous line, the template that you can see, my input data is interface name is gigabit 000, and if I pass it here, the second condition is matched, and that's why it will print this one. Okay. The third rule is loops, and it has for loops and it does not have any while loop. So you might have other languages where you have while loop as well, or do while loop, but it just only have for loop. Now this is combination. You can do the previous examples that we have seen, and you can run it multiple times as long as the condition is true. It will do it. So that's when we use for. So here I have a variable called interface underscore name, and I have several values in a place called interfaces, and every single value in that array will be treated as the variable interface name and will be used here to generate multiple output. And let's say I want to make several interfaces based on this condition to bring it up with no shutdown command. That means I want to pass it through the for loop. So let's say I have 3 interfaces here, and all of them are put in the interfaces variable or interfaces array, and then each of them are counted, passed through this for loop, in this for loop, and the second line, as you can see, interface, and then the 2 curly bracket means it's a variable, and each values here will be used for this variable, and so it becomes interface, that interface, no shutdown. So you'll see the output will become like this. Every single interface will have a no shutdown command. Now the SLS as the salt stack state, this file format is a combination of YAML and Jinja together. So whatever rules you have seen in the first 3 examples, and then the second 3 sets of examples are for Jinja, it can be together. So on the left side, you see pure YAML where we have a list of values for interfaces. And on the right side, I have a for loop, and I'm using the YAML syntax there as well. As you can see, I have a dash somewhere in the middle, and as you can see, the interfaces. So this I will be replaced with the values corresponding values sequentially for the interfaces. And then eventually you will get the list printed on the left side. As you can see, that will be the output from the SLS format. So it's basically SLS files are a combination of YAML and Jinja together. There could be many other, but this is the default. So Meko JSON combination can be possible. And there are Cheetah, Gensi, and the representational format can be JSON, TOML, JSON5, and any other. So here's an example. The default is Jinja YAML. If I want to use any other combination, then I mentioned it at the top line, as we do when we do the bash script, we mention what is the interpreter, similar thing. Okay, the salt minion configuration. Let's do some of these. So we are showing 3, but there could be many. And Napalm is the most popular and very widely deployed because it's open source. So vendors and communities, they actually build many modules around this Napalm, and that's why you see a huge support by different vendors. Not just Salt, it also is by many other automation tools. So what Napalm can do is configuration replace, means you can have a complete different set of configuration and you can push it to your running config, it will be used there. So this is like a complete replace. You can do a merge, means you update the configuration, the previous configuration will a set of configuration from the previous configuration might be replaced. Let's say you change the IP address of interface, it will be pushing this configuration to the config. Config compare, this is probably coming from Juniper, and you see in Juniper, if you are working with Juniper routers or other devices from Juniper, you should see that your current in Juniper. Yeah, so I'm saying like in Juniper, if you are configuring something, you have your current configuration, and whatever configuration you are doing, it keeps it in a separate kind of a, you can say kind of a location, and then you can do a comparison of what changes you are going to make if you apply this configuration. So it's like a comparison. But if you are working with Cisco, Cisco iOS, you don't have it. You apply the config, it's applied, that's it. You don't have a separate location, it's saved, and then you don't have the option to compare. Same thing for MikroTik, same thing for Huawei, same thing for Arista. You don't have this compare, actually Arista has. So many different vendors has the configuration options applied immediately as soon as you give it. Now, if you're using Napalm on a Cisco iOS router, you still have this compare option like a Juniper router, you see? So it's not the OS itself, it's the Napalm module that's giving you the option to compare the configuration. So configuration compare is possible for a device that natively does not support it. For example, Cisco iOS, iOS XE, MikroTik, Huawei, and these kind of devices. And then discard is you don't want this config, you want to roll back, you want to discard the config and want to apply the previous one. Commit is again probably coming from Juniper, also Cisco iOS XR has it. It's not the behavior, like I said, some devices, you give a command, it's applied immediately. But here, Napalm can give you this option of when you write commit, when you apply a configuration, it's not immediately commit, it's not immediately applied. You have to write commit and then it's applied. So that option can also be available for devices that does not natively support it. Rollback is similar feature that natively probably not available for many vendors, but Napalm, with Napalm you can give this, you can get this feature, which is I applied it, but I really don't want myself locked out, or I'm worried that this might have some different issues. I want to roll back after some certain time. So let's say 1 second, 1 minute or 30 seconds or something like this. But if I'm happy with the output and I want to confirm commit, so that's called commit confirmed. And I can then apply a second commit, which will apply because I'm happy with the result. If I don't do that, it will return to my previous commit, and I still have a chance to make changes and try again. How we install it? This is the Python package manager, pip, and then you install Napalm. NetMiko, not really very extensive module as Napalm, but still it gives you options to configure. It's an open source again. So yesterday, if you have listened to one of the presentations where they used NetMiko to configure their router. PyEZ or Junos EZ-NC, it's basically Juniper made, only used for Juniper routers. No other vendor supports it, but Juniper has extensive development of this tool for their own automation for their products. Kapirka is not really a module to do the config management, but it's for the ACL generation. So it's a ACL or access control list generator. And it's originally built by Google. Later, they made it open source, and the Salt community utilize it. So what you can do is you can tell the vendor name, and you can tell what you want to do with this IP address to that IP address, and then it can generate a vendor-specific syntax for you. If you say, I want a Cisco-specific syntax for this ACL, it will create a Cisco-specific syntax. If you want Juniper, it will create a Juniper-specific syntax. And there are many vendors support here. So that means it can actually generate different types of very well-known, very common vendors syntax. Here's an example. So this first line is a command done in the master and the salt. And then the next part is device. As you can see in the code, it's basically the target, which is a minion, not the device itself. It's the name of the minion. And then you are using the Kapirka module, and the function is this get term config. And then you mention what vendor you want. Let's say Arista, and then your name, filter name, your term name. Many vendor does not have a term, so it will become a description or a remark. And then you say source address, destination address, and what is the action you want, whether you want to drop it or you want to permit it. And then because you wanted Arista, it will make Arista specific command. Yeah. So that's when the grain data will become useful, because the grain will give you the information of the operating system. And it will understand it's an Arista device, like an EOS device, and it will generate it. If it is a Juniper, the minion maintains a Juniper router, the minion will gather the information, and then it will create a Juniper specific ACL. It's very cool. And in the lab, you'll see, in the lab description, you'll see that. Okay, how do we configure master? When you install master, a couple of things you have to do is, one thing is from where the configuration data will come. Remember I said pillar is configuration data. So first thing is where Salt will find your configuration data, you need to put it somewhere. And it can come from different sources. It could be somewhere and you can have an API connection, you can collect it from there. It could be in a Git repo, it could be in static files. So when you put it in a static file, you need to put the location of the file. And then that's where in the config, as you can see in our Salt config, master config, we have a file called pillarroots.conf. And in that place, we have the attributes like pillar roots and then corresponding location. You can have multiple location, and Salt master will look for the configuration data in all this location, whatever you put here. The top file is a very important file. If you have many different many minions maintained by the master needs to know which minion will be executed with which config file or which pillar data. So here's a mapping, is an example. where we put a couple of logic to match the minions. So as you can see, that first one is a star. That means all the minions are a match here. And then the common.sls file config will be applied. So here you don't really need to use .sls, but common.sls is the name of the file. So all the minions will be applied with whatever configuration I have in common.sls. And then the next logic, I have group star. Means if I have minions with the ID of the minions that starts with group, and then any number, any character combination is going to be a match here. And then group common.sls config parameters are going to be applied there. And it will continue looking at other logics as well. As you can see, I have a specific group 100, and for that I have a config. Now, this is not like an ACL. It will continue reading even if it is a match. So it will finish the whole logic, whole instructions of this file, and it can apply with multiple of the configs if they're a match. So for example, if I have a group 500, the name of my minion or the ID of my minion, then common.sls and group common.sls, these two instructions or these two pillar file will be executed because both of them are a match. But if I have a file called, if I have a minion called server, then only common.sls will be applied. If I have a minion called group 100, then three of these files like common.sls, group common.sls, and group 100 underscore data.sls, all these three instruction files will be executed. File roots are for static files, templates, and because this is the root of the file, so you probably usually have the static files there. Now, if I have templates like Jinja templates files, I can put there. So if I can put multiple file locations, and Salt will look for each of the locations. Now, how do we configure the Salt proxy minions? Now, because I said proxy minions, so minions are supposed to live inside the device, but because the device does not give me the option to install the proxies, the minions, so I put it out of the box, and that's how it becomes a proxy minion. And so I have to configure the driver there and the proxy type, how this device will maintain the connection with my target device, how this minion will maintain it. And we already covered some of the different types of proxy minion configs or drivers. The module that we covered, NAPM, we can utilize here. As you can see, for my router 1, I have a proxy connection parameters here. And then you can see that the NAPM and Junos is my driver, proxy type is NAPM, and this is the host, which is usually your minion ID. And then its username is password, and not necessarily has to be here in plain text because it's a security concern as well. You can have it somewhere else, and it can be more secure to get authenticated. But remember the top file, and this is how it's gonna be now used. In the top file, I said router 1, this minion ID will apply router1.sls file. And as you can see, router1.sls is the first example and how it's gonna continue connecting and maintaining the connection with my target device. That's how it's gonna be executed. This is an example with Junos Pi Easy NC. This time you don't really need to have a driver because it's only supporting Juniper routers, so there's no driver needed. It's just a proxy type. The top file is similar. The third one is the NetMiko. And this time again, you need a driver because NetMiko is open source. It supports multiple vendors. Okay. We'll now go with the, so we have a workshop track at APNIC. So we cover network automation training on Salt. So we have a lab task, like it's a 4-day or 5-day workshop track that we do. That means we have several lab, but every tasks are here in this GitHub repo. And my colleague Makito is going to cover, but it's very extensive. It has about 16, 17 tasks because we do that 4-day, 5-day workshop. But this, because of the time limitation, Makito is going to go through as far as we can. And if you're interested, you can build the lab by yourself. Make sure you choose the right OS, because not all the OS, because in this lab, we have about 4 different types of devices: Cisco IOS, Cisco IOS Exa, Juniper, and Arista, and some servers, like Linux servers. Now, if you don't choose the right Cisco IOS, Exa, or Junos, actually Junos and Arista mostly support it. So you need to configure the netconf there. So we tried some of the OS from Cisco virtual routers, and some really work very well. So we use them here. So you also need to know. So these are a big lab, but if you want to build it by yourself, you can start with 1 router, 2 routers, and see how it goes. So the instruction here is not to go to your office and just use Salt and immediately start doing this, because there are many other tools as well. And you need to identify which one is better for you. And you can use a combination of different tools as well. So it's just up to you. You have to do some research and do some trial, and then you decide what could be the best method of doing it. Okay, so I'll hand over. Oh, so by the way, do you have any question before I hand over to my colleague? Because these are the real examples. And yeah, okay, please go ahead. We don't want questions. No questions allowed.
Hello.
Yes.
All right. Thank you. I have a pretty basic. I am not sure if I missed in the first few minutes, which is I'm pretty familiar with Ansible, and why we are going over Salt and all the ecosystem it has, other than going with Ansible for the automation part. That is one question. And another one is, can we fit Batfish into this ecosystem other than Ansible?
That's a very good question. I actually covered this a little bit at the beginning, that I'm not really saying that, if you are doing Ansible, that's really not good and go for Salt. So we could have introduced Salt, and we did in some other workshops. We actually did introduce Salt. And then this is like a new, something new we are going to introduce, but it's not new in the community. Already many companies are using it. The good thing that you can see that both of them has similar libraries, similar syntax. So if somebody is familiar with Ansible, they could be really very good in doing this one as well. So it's not, the main reason is that not that we are presenting something which is better than any other tool. It's just introducing a tool, that's it. And not really very specific reason for that. We're just doing it. Yeah. Anurag, go ahead.
Hi, Anurag Bhatia, Hurricane Electric. I don't have a question, but just wanted to reply to Shamim. So I have a funny story to share. One of my friends running root server operation for one of the root players, he once mentioned on how they moved from Ansible to Salt, and to deploy Salt minions essentially on the client side, they used Ansible.
Okay, that could be a good convincing,
and about specifically about the Ansible versus Salt. So I think, yeah, sure, Salt is more powerful, but then most of network operators have to ask, do they need that much power? Do they, if you are saving 5 seconds in running an operation, does that matter if you are going to do that on 5, 10, 20, 30 routers or switches or servers, versus if you got 10,000 virtual machines and thousands of millions of containers, then maybe that speed would actually have a real world impact. Thanks.
Totally agree, and very good point. And thanks for saving me here, actually. So, a big router can do BGP and can take full routing table. And I'm an ISP. Do I really need to buy it or not? It's my decision. I have to do this workout. Like, I can just run default route. That's may not be the best, but still, if it is okay for me, and I really don't need to invest that level of huge capacity in my network, yeah, probably it doesn't make sense. But there could be many other companies who might need that. So it's just their individual assessment, how they come up with the idea. But like, it's a very good thing that I didn't know there is an example exists that you run the Ansible to run the containers. And that means you are making both party happy, you know. So yeah, I would suggest that the technical expertise of the team is a very important thing that we need to consider before implementing any new tool or introducing a tool to the network. I need to also know whether my team, my colleagues, all of us, we have similar, you know, working expertise on that or not, whether my infrastructure needs that level of complex setup or that level of, speed or not. So right reply from Anurag. Thanks for that. We can actually continue this discussion during the break as well, but quickly handing. So any other question? Yeah, please go ahead.
Can you going back to your proxy minion architecture, the slide?
Oh,
Or okay.
yeah.
If I taking picture of proxy minions,
Yeah.
the master to the proxy minion is using a 0MQ
Yeah.
communication, right?
Yes.
And from the proxy minion to network device or target device is using HSH.
Yeah.
So if we compare with Ansible, Ansible engine is going directly to target device using HSH. So if you compare between this architecture and Ansible, does it make a Salt is more faster push configuration to the target device comparing with Ansible?
That's a very good question, actually. One of the big differences here, I think. But if your device supports netconf, you would get a faster experience compared to SSH. And I think Ansible, I think that that can be a difference here. But I would say, like, again, the same answer, if you really don't have that level of need of being very fast, and then you don't really see the difference that much. But if netconf is something, you can use NAPAM as well. So not really a big difference in that sense, unless you have a huge number of devices running across multiple continents and things like that.
So we can use another alternative like a netconf between proxy minion to network device.
Oh, you have this, you have the options to connect. So several different options. So some legacy items, some different vendors, they may not support netconf. SSH could be your way to do that. Yeah.
Thank you.
Thank you. Handing over to Makito. Okay. So we probably don't need the slide deck anymore, right? Thank you, everybody.
Okay, so now I think everyone can see my screen. And coming up next, I will show you some examples on the GitHub, because for this network automation workshop, actually we have all the lab configuration and example instruction in the GitHub. And you can click on this link, then it should bring you to the GitHub page. Let me see if the text is big enough for you. Okay, so I will walk through the first a few topics here, but as you can see, there are totally actually 17 labs, because this is typically used in our network automation workshop, which will last between 3 to 5 days. It depends. Sometimes if we are running 3 days, we might arrive to lab 12, and if we are running up to 5 days, then probably we will finish all the 16, 17 labs. Okay, so the first one that I'm going to show you is how to do the installation. This one I will go quickly because I think all are very basic. How to install in Linux. First of all, of course, you need a Linux machine and you will need some Oh, my screen is lost. Oh, it's back. Then you will need some dependencies. You need some packages here, like what we listed here. Actually, in our actual workshop, we will pre-install those packages. So our participants, they don't have to install every package. But in this case, just for your reference. And in our lab, typically we use Debian, which is in this version. For the installation, typically you will need to add the key and you will need to add the source to the repository list. Then you need to do the update. Then for installing the salt master, it is as simple as this. You just use the apt-get install salt master. And for the minion, same, you just need to install minion, salt minion like this. Most of the time, your master and minion will be on different machines, but for testing purpose, technically you can run them on the same machine. And after installation, this is just for verifying your salt version, salt master version, and what are the dependency versions here. So this is the lab one. And next I will go to the second one about after installation, how you will configure the salt master and minion. We will start with the minion. For the minion configuration, there is a configuration file in etc/salt/minion. And inside here, there is one main point that we need to configure, which is who is the master. In this case, because in our lab, we run the minion on the local host. So that's why master is also localhost. It is the same machine in this case. And then this is how you can start your minion in the debug mode after the configuration. In our lab, we try to start with the debug mode because we want to show to the participants that when the minion started, what the minion is running or what it is doing. Like, for example, sending the request to the master. And in this case, because we did not start the master yet, that's why it is showing some request timeout error. And of course, you can run the minion in the background by using -d here. For the master, there is also a debug mode. You can run with the debug mode if you want to see all the details, especially at the beginning. You want to know that whether any error or any configuration not running properly, then you can use the debug mode. And then as we mentioned in the presentation earlier, we will need to accept the key of the minion in the master. So in here, you will see actually there is a minion called group 100 is trying to connect to the master. So in this case, if you use the -L, you will be able to see what are the keys accepted or denied or unaccepted. In this case, we need to accept this one. So that's why here we have a command to accept the key. And here it is a variable because earlier, if you notice in the lab instruction, we let the participants just take note of the minion ID. Technically, you can directly type the minion ID anyway. And after accepted, you should see it is in the accepted list and they should be able to work with each other. And next, you can do something like this. For example, you want to test ping. Just make sure the reachability, the communication between the master and the minion, are they okay with each other? If it is returning true, then yes, it's working. Otherwise, you may see it is stuck for some time and finally you will see some error message or it will return false. And the next part in the instruction here is talking about the pillar routes. This one, I believe in the presentation earlier, I will mention about that. It's the place that we store the configuration file for the pillars. So in here, the syntax will be like this. We can configure multiple environments. And in each environment, we can have the directory that we store the configuration file. For example, we can do like this. This is the base environment. We will store in SRV salt pillar directory. While in another environment, we can have a different directory with different configuration. So after we configure the directories, make sure we have to create the directories and store the configuration file accordingly. For the top file, this one also, as we show in the presentation a bit earlier, we can have the configuration for each specific minion ID, or we can match it using like star here. It means that match everything, or group star means something starting with group and with something behind. And in this case, group 0, 0, it will match specifically to this minion ID of group 0, 0. So imagine if you have a minion ID of group 0, 0, then it should match all of these, because it will match anything with the first one, and then the second one, anything start with the group will match, and then the last one, it will specifically match the value of group 0, 0. So this minion will basically apply all the configurations that we configured here. And as Awal mentioned, if it match multiple items like this, it will not stop at a specific item. It will go until the end of the list. So it means that if you have the overlapping keys, for example, if you have the same configuration like this, let's say there is a key called group comment equal to true in the group comment configuration file, while you have another group comment equal to false in the group 0, 0 file. So if it match both, then finally the value will be set to false, because it will first set the value to true, then next it will realize that this is false. So finally the final value will be false, because it will not just stop at the true place for the case of group 0, 0 that I mentioned earlier. So this is how the pillar files work. And the next one, we will talk about the file roots. This one is for the case of, let's say you want to retrieve a file, specifically like a text file from the master to the minion, then you can retrieve through this. Then you can configure the directory, the root directory of the files. For example, in this case, it is srv sort. Then we can store a file. For example, now we create a file called example.jinja here, and then just have the content. You can write whatever inside. Actually, this is just an example. This is a dummy template. Then after that, when you go to the minion, you can actually copy and get the string from this file using the syntax like this. Then you will get the return of the content of the file. It is an easy way that you can retrieve like a configuration file on the master. And the next part of this lab instruction is talking about whether to configure open mode. By default, as you can see in the previous steps, we need to accept the key. If you don't accept the key, the communication will not be okay. So if you are doing the test only, you don't want to accept each and every key, then open mode can be an option. But definitely this is not recommended in the production network. In the production level, you should always have the authentication. So this is end of the part 2, which is talking about the basic or general configuration of the sort master and minion. The next one that I'm going to show you is the proxy minion part. This one is in the case of your target device cannot install a minion, then you will need to use proxy minion. For example, you want to manage the router, then you will need to use one of these options. We have like Napalm, NetMiko, and the Junos specific one, I believe earlier Awal already mentioned in the presentation. So I will show you one by one. The first one is Napalm, which supports many vendors like Cisco, Juniper, MikroTik. So like Napalm, you can use with many of them. You can use the single, can say, library for different vendors. And the configuration would be in here in the pillar directory. For example, if this router one, it is a Junos router, and then I want to use Napalm, I can configure the proxy type is Napalm and the driver is Junos. This driver part will be depending on the vendor of your router. If it is Junos, will be Junos. If it is Cisco, it might be iOS, or depending on which type of iOS, iOS XE, iOS XR, and if it is other vendors, just need to change according to that. And this is the username and password. And then in the top file also, you will need to point For example, this router 1 minion ID will use the router 1 SLS, which is the one that we are trying to create above here. So this is the configuration for router 1. And then in top SLS, we need to say that this minion is using this configuration. And then after that, you can run salt proxy with the debug. This one is at the beginning if you want to see the details, each step. And as the question earlier asked about the protocol between the proxy minion and the router, it really depends on which type of router or which operating system that the router is running. Some operating systems might be supporting like netconf, while some only support SSH. So in that case, if the operating system is supporting netconf and Napalm is preferring netconf, then you will see the details exchange on the netconf. You will see what the proxy minion and the router communicate. It will bring out in the debug mode. And in the case of SSH, then it will be just SSH. And yes, this is for accepting the key if you did not configure in the open mode. And in our lab here, most of the time we will tell participants to do the test ping because this is the basic one. At the very least, you should be able to ping before you do anything. Yeah, so this is the Napalm part. And then the next one is the Junos one. This one is the specific one for Junos. It supports only Junos. But as Awan mentioned earlier, it is more optimized for Junos. And I believe it will run on netconf. So in this case, you just need to configure the proxy type is Junos. You can see compared to the previous one we will say proxy type is Napalm, and we need to mention the driver because Napalm supports multiple vendors. While this one, the Junos one, it supports only Junos. So you don't have to mention about the driver anymore. It is just only Junos. And then the same running steps. Then finally, if you test ping, it's working, then it should return true. And this is an example command of getting the grains items from the router. For example, you want to see what is the version of the router, the platform, it will give you detailed information that it queried from the router. The next one is the NetMiko proxy minion. NetMiko is working on SSH, and this is, I would say, if you have the choice, you can try to go to Napalm and the Juniper specific one before you use NetMiko, because NetMiko is the one that you can send a raw SSH command through the SSH to the destination device. So it is not like there is existing function that they pre-program for you. You will need to send your configuration command. For the configuration, you will need to configure proxy type, NetMiko, and device type here. This is the OS. And then this is test ping. And as I mentioned earlier, in NetMiko, you will need to send the command like this. For example, show version. So this one, it will have the difference between the different vendors. If you are using Cisco, you will need to send the Cisco command. If you are using MikroTik, then it should be different command syntax because it is just sending the command to the router. Yeah, so personally, I would use it as the last option. If I still have other pre-programmed functions that I can use, it would be better. Then the next one, I will talk about the CLI syntax. Actually, in our lab, typically we set up like this. We have the Juniper router, we have the IOS XR router, we have the EOS from Arista, and the Cisco IOS. Then we have different vendors like this. In this lab, we will try to use the matching syntax to target different devices. You can ignore some of the information here because this is when you actually run the lab. Maybe in our lab setup, we are changing the the lab device. So there are some SSH error showing this. This is for specific for our lab. So this is the main part for this one. If you want to target the specific minion, then you can just put the minion ID. This is the basic one. For example, I want to target router 1, test ping, and spine 1 to get the grains, and specifically want to get the version. Then here it will show the version of this operating system. And the next one is, for example, you want to get the pillar and get the proxy part of the pillar. Then it will show you for this minion, for the proxy, what are the values that we configure. So this is targeting a specific minion. You just mentioned the minion name directly. Then if you want to target a list of devices, then in this case, you can use the -L here, this option, and then you can mention the list by using the comma to separate them. For example, router 1, comma, router 2. In this case, it will target these two devices and do the ping. Then you can see here, router 1 and 2 will reply. Just assume that everything is working. And actually, there are some other options as well. Here it is telling to go and read the information in the help manual about each option. Actually, if you search it in the SALT website, you should see, let me enlarge a little bit, then you should see different options. For example, if you use -E, it is using regular expression, -L, it is with the list, or -G is querying with the grains. So yeah, there are many options. We will show one by one in the lab. The next one, it is the shell-like globing. This one is like, for example, you want to match like this, anything start with leaf and leaf something. Then if you use leaf star, then it will target to all the devices that start with leaf, which in our lab situation here, it is leaf 1, 2, 3, 4, I believe. It doesn't show on the diagram. And if you want to target, for example, spine 1, 3. So in this case, it means anything start with the spine and followed by number 1 or number 3. So only spine 1 and 3 will return the result because only these two will be communicated. And in the case of you want to say, I want to get spine, but anything besides 1 and 3. So you can use the exclamation to say not 1 and 3. So this collection will not be communicated. Then you will see the response from 2 and 4. Because actually in our lab setup, we have 4 spine routers in that case. And this one, part 4, is the regular expression. It is -E, as I show you in the instruction here just now. It is for matching using regular expression. So it's a bit more flexible. You can write more complex pattern to match it. Like in this case, it is a simple one actually. It means that spine and followed by any number. So in this case, it should match all the spines. And for part 5, this one you can target using the grains. For example, you want to match only the devices that are Cisco devices. So in this case, you can say -G and match it when the vendor is equal to Cisco. So in that case, only the Cisco devices are matched. And if you have a look at our lab diagram here, we have the core routers here, which are the Cisco IOS XR routers. And then we also have here, we have Cisco IOS, which is the leaf. So this is the reason why here you see it is matching core 1, core 2, leaf 1, 2, 3, 4. The next part is we also match the grains, but in this example, we want to match with the regular expression. So we can use -P. So in this case, we will match when the OS is equal to iOS, but followed by something. It can be iOS XE, it can be iOS XR. So in this case, it should match all the Cisco devices, which it does here. You can see leaf 4 is iOS XE and core 1 is XR, leaf 1 is XE, core 2 is XR, while leaf 3 and leaf 2 are XE. So it simply just say that, okay, I want to match anything which starts with iOS and followed by something. This one, the regular expression, you can use your creativity to do any matching that you want. The next one is matching using the pillar. For example, I want to match anything that it uses the driver of iOS XR. And then when match, I want to load the configuration of set NTP server. because sometimes different operating systems, they use different syntax, totally different syntax. So in that case, if your syntax is only for XR or only for, let's say, MikroTik, then you might want to match based on the specific platform using the driver. So in this case, it will only match the two XR routers, and then it will apply the configuration. And then the part 8 here, we are saying targeting using the regular expression to match the pillar. So this one is very similar to the previous one that used the regular expression in the grains, but this time it is just targeting the pillars. So for example, we want to match the one with the host name of the spine, followed by number 1 or number 2. This is the regular expression part. Then it should match the spine 1 and spine 2. Yeah, so this is end of the lab 4. These are just the basic example. I would say very, very basic example on how you can use Salt to do your automation. And as you can see here, after the lab 4, we still have lab 5, which focuses on the configuration management, or lab 6, talk about the salt states, lab 7, text FSM, that talk about advanced text matching. For example, your output from the operating system is like this, but you want to match the specific value. Let's say in this output, what are the key points? You may want to get the MAC address, you may want to get the version, you may want to get the free memory. So you can write a template like this, and then finally it can produce the key pair, key value pair for you like this. Then you can get your important information without needing to, extract it manually from the text. Okay. So I suggest to have a look. And also we have like event bars. This one, it is talking about the event in the salt. And we also have napalm log. Also, we have some other things like reactor, including API that can integrate with the external system. Yeah, so Salt is a powerful system. You can do many things. I suggest if you set up your own lab, you can go through this repository, see each and every lab and see what you can do with Salt. Today, due to the time limit in our tutorial, we cannot show every lab. As you know, this is a, for 3 to 5 days workshop. So I will just show you up to this point. If you want to access the lab, just go to GitHub and go to our network automation lab repository. Then you should be able to see all the content. Okay, so before we finish this session, do you have any question, or Awal, do you have anything to add? Okay, looks like no question, and Awal did not want to add anything as well. So thank you very much for your participation in this session.